Okay, so with these, they're going to react one of two ways. And you can either think of the acid-base reaction as a double displacement or a Bronsted-Lowry. So there are some things that can only be Bronsted-Lowrys, but there are others that you can kind of see them as being both double displacement and Bronsted-Lowry. So remember, when you've got a nitrogen kind of a group right there, that nitrogen group is the one that's going to need or accept the H. So anything with a nitrogen behaves like I'm demonstrating. You've got the NH4 plus, and then you have the Cl minus. So it does this thing where it gains an H. And then things reacting with water are going to do the same kind of thing also. And those actually have two lone pairs. And again, they're going to gain the H, and that's going to make H3O plus Cl minus. So you can see I'm not doing a double displacement because I'm actually gaining an element here, an H, and then losing over here. So double displacement is like an even trades of positives and negatives. So things like water, nitrogen, basically things that have these kinds of lone pairs sitting on them that can do things because they have lone pairs, those ones have to be categorized as the Bronsted-Lowry situation going on. Now, if you go back and we look at the double displacements, you can actually see these as like proton donor stuff, but it gets a little bit more confusing. You can also just see them as a double displacement. This is our positive part here. This is our positive part here, and we just switch them. So you have NaCl plus HOH, which is the same thing as saying water. And then in this one, you have to know where the H is. Remember, we've talked about it's there. That's where our positive H is. This compound is negative without the H on it. And then we've got our Na right there. And so those are just, like if we're trying to write those as doing some kind of a reaction or something, that's going to give us CH3COO minus with the Na plus. That's going to neutralize. And then this gives us HOH. So you might be thinking, well, how do I know which one it's going to do? How do I know? How do I know? Well, basically, if one of the things in it isn't positive negative, like positive negative, if it's like NH3, like it's not an obvious positive negative because that's a covalent species right there, or like the H isn't in front. And then water, also anything with water is going to be doing this accepting, dropping off business going on. So this is kind of another reason that we came and we started talking about Bronsted-Lowry, because now we can see that like this reaction right here, that reaction is going to not give us any H3O or OH minus. It doesn't give us any of those, but we still know that that's an acid-base reaction.